Okay, this is Fawad Masood, and this is just a review of what internal forces are. Those who are into civil engineering or even architecture, they need to calculate the internal forces, and especially we're talking about beams or flexural members. So it's a very introductory lecture. It's the basics that we are going to talk about, and well, the first question: why internal forces are needed? Generally, beams, columns, slabs, these are all the structural members that tend to support or that constituent a building structure. And similarly, other structural members, they are all subjected to forces. The idea behind having those kind of structures is that they bear the load and then they transfer the load on to a structural member lower than them, and eventually it passes down to the ground. Now, whatever structural member we are talking about, the load they're taking, they need to be designed specifically for that amount of load to ensure the safety of the structure, and so that the structure or the part of the structure doesn't collapse. This is actually a photograph from a competition that we organized as a part of coursework during the last semester, and the students came up with two identical beams. One of them was tested right away, and the other one was strengthened. The strength was enhanced, and then it was tested to see how much more load it can take and against what kind of what cost. So it was, strength gain versus the cost comparison, and this was more of a competition. We really had fun. This beam failed. This was a test specimen and it failed. It took like 100 kgs something. Now, when we say the word failure, that means collapse or breakage of structure. It may not totally dismantle, but the idea is that it's not able to take any further load. That is the basic idea of structural members collapse. Again, this is another beam that was tested and took a lot of load. You can see the weight spread all around. Okay, to design a structural member, say a beam, one needs to determine the forces that are developed internally. So there is some external force being applied, and as a result of that external force, some stresses or forces are induced internally. These internal forces are a result of externally applied forces, like I've said, and to make sure that each part of the structural member is in equilibrium. We'll talk about this thing. I'll elaborate this in a while. Later, these internal forces are used to design a structural member that can sustain all of these internal forces to ensure safety and serviceability. Safety in general means not letting the material fail or break. Again, this is another beam that was strengthened and that was later on tested during the same course of competition. Now, there is another term that we have to take into account when we are designing a structural member, and that is serviceability. Now, serviceability, this refers to the deformations. You can see large deformation in this particular beam when it's being tested, and formation of the crack at the center as well. So when we refer to the term serviceability, that means we're talking about the excessive deformations or the deformations and the crack formation. So if something is meant to be serviceable, that means it should not deform much and should have lesser cracks. Now, the method that we are going to use for determination of internal forces is termed as method of sections. In order to calculate internal forces, you'll use this method and you'll form some equations for different types of internal forces, and those equations will be used to determine the internal forces. these equations not only help in obtaining the numerical values of the internal forces, but also in plotting their graphs against the length or the distance. Whenever you cut the section, it exposes their inner part of the object. We are a foodie nation, so I'm going to give you an example of an edible. So consider a chocolate. As long as that chocolate is intact, whatever is inside, you don't know that. And the internal filling will only get exposed when the chocolate is cut. So there is this chocolate that is as a whole, and you don't know what's inside. But once I get to cut these chocolates, you get to see the nuts or the fudge or the resins and fudge in the combination of all, or if it has wafers. Similarly, the forces acting in a beam, within the beam, internally, will only get exposed when the beam is cut. So this beam that you have right now, these are external forces, but you cannot see what's inside until and unless you'll cut a beam. So when I cut this beam into two parts, you get to see three kind of internal forces. This one is along, this is parallel to the length of the beam, so it's called axial force, and then there is this perpendicular force, this one, and this is called shear force, and then there is this bending moment, and you can see identical forces on the other side of the beam. So both of the sections would show you similar internal forces, just like the chocolates, which had similar sections or similar internal forces, as we could say, on either sides. So axial force is the first one, and that is parallel to the length, and the other one is shear force, that is perpendicular to the length, and the third one is bending moment. Now let's talk about axial force. Again, like I've said, axial force is parallel to the length of the beam. It's denoted by A, and this is how it looks like. Since it's the axial force, it tends to elongate or shorten the beam. And you must know Mr. Fantastic. He is from Fantastic Four, and he can elongate as well, as you know. So just reference from the comics. Now shear force. It acts perpendicular to the length of the member. It tries to cut or slice the structural members into two parts. And I always use the example of a cake. You cut it or you slice it, so you're actually shearing off the cake slices. And this is again cutting or shearing of a cake. Now this force is denoted by V, and this is how it looks like. So it's the perpendicular one. Now we talked about parallel forces and we talked about perpendicular forces, but if you have an inclined force, it's going to be resolved into parallel and perpendicular components by using sine theta and cosine theta. So if there is an inclined force, that's going to form both axial and shear force in the beam. Now the third force, that is called the bending moment. That is the moment that is produced internally by the force applied externally, and its moment arm. So force into distance would give you moment, and that moment when acting internally about a particular point, about the point where the section is being cut, that would be the bending moment or the internal bending moment. You can denote that by a couple forces as well. So the force is there, the moment arm is there, the couple moment is there. That's how it is. And again, you can see a beam that is being subjected to some load, and it's again a photograph from the competition that we organized. So you can see the beam is being bent, and that's what the bending moment does. It bends the object, and that's what the name suggests. So we'll talk about this reactions in the next video. So we'll stop here and hope to catch you soon.